In this video, we discuss how to use GeoGebra to compute a confidence interval for the difference between two means. We'll use the example here that examines the ages of leading actresses and compares that to the ages of leading actors. So the summary statistics are here. There were 84 leading actresses sampled. The mean age was 35.6 with a standard deviation of 11.3 years. And then among the leading actors, we have a sample of 84. The average age for leading actors is 44.7 years with a standard deviation of 8.9. So what we want to examine here is to see if there's a difference between the mean age of leading actors and the mean age of leading actresses. And to help us do that, we're going to construct a confidence interval trying to capture the difference between those two means. We have to verify that the conditions are met before we can use the t-distribution. And if we were to do this by hand, we would calculate the point estimate, find the t-score, the standard error, but we'll do this in GeoGebra. But before we use GeoGebra, we do need to verify the conditions are met. So we need to have independent samples, which we can assume here, and then we have to make sure the sample size is large enough because the underlying distributions don't appear to be normal. Well, we have 84 and we have 84 in both of the samples, so 84 is more than 30. 30 is our rule of thumb for the sample size required. So the conditions are met. We have two separate independent samples, and the size is greater than 30 in both of the samples. So we can go now to GeoGebra to calculate this. So to open up, to find the confidence interval calculator, we need to open up the probability calculator. We need to go to Statistics, click on the drop-down menu, and go to where we have the t-estimate. We're using the t-distribution, and it's a difference of means. So we want it to be 95% confident, so we put in our confidence. It's already there, 95%. So the first sample will be for the actresses, so we'll put in 35.6 for the actresses for the mean. The standard deviation is 11.3, and the sample size is 84. Then for the leading actors, 44.7 for the mean, 8.9 for the standard deviation, and then there were 84. And right away we can see the results. Let me change this a little bit so we can see the results a little bit more clearly. The lower limit is negative 12.19999, rounded to 4 decimal places, and then the upper limit, negative 6.0001. So this is our confidence interval. And now we want to interpret it. So we're 95% confident that the difference between the mean age of leading actors and the mean age of leading actresses is captured by the interval from negative 12.1999 to negative 6.0001. So notice that 0 is not contained by this interval. So what that means is we can conclude that there is a difference between the mean age of leading actors and the mean age of leading actresses. So there's a difference. Who's older? Well, since the interval consists entirely of negative numbers and we're subtracting the age of actors from the age of actresses, we can conclude here that leading actors are older than leading actresses.